Good morning, good afternoon, good evening. Welcome and happy holidays, everyone out there. You are here for the Cisco Wi-Fi 7 launch event. Thank you, Ekahau, for sponsoring this event for us. We have hundreds of people here on the line, and this is going to be a really exciting launch of our Cisco Wi-Fi 7 technology. We have an all-star cast here today. I mean, you're stuck with me as your MC, but we have some amazing technical presenters that are going to be joining us. So I'm your host, Jeffrey Gelino. We have Drew Betts, the solutions engineer from the Cisco Wireless team, joining us as well. We also have Jim Florwick. Jim is a principal technical marketing engineer for Cisco, probably one of the best Wi-Fi heads that I know out there. And then our very special guest from Ekahau, Matt Starling. Matt is director of product at Ekahau and an amazing wireless advocate. You've probably seen him on LinkedIn talking about all sorts of amazing wireless deployments that they've assisted with. And we want to thank Matt and the Ekahau team for joining us here today. And yeah, why are we here today? It's for the Wi-Fi 7 AP launch. So brief agenda and what we're going to be getting into today. So I'm here for the welcome. Welcome, everybody. And there is going to be a giveaway today. We did promise that. So we are going to be giving away 2 Wi-Fi 7 access points. We also have 5 Ekahau swag kits. How do you become eligible for the giveaway? Well, if you're here now and you can hear my voice, you're meeting criteria 1, which is join on time. You also need to stay through the end of the session. This is a long session. I do appreciate that. It's going to be 90 minutes, but please do stick with us to the end because we have just 90 minutes of action-packed, informative content here. So be here now, hang out to the end. And then the last way is, way to influence your ability to win is to participate in the chat and ask questions in the Q&A. So yeah, hello everybody out there. Thank you so much for hopping in. That's awesome. We do have panelists that are in the chat, in the Q&A. Please do ask questions in the Q&A. We have top engineers ready to answer them. So again, this event's going to start off, and I'm going to take you on a little journey in how we got to this very pivotal moment for Cisco wireless technology. Then I'm going to hand it off to my good friend Drew Betts. Drew's going to go in depth of the Wi-Fi 7 launch, the hardware, the features, the dual platform. Oh, it's going to be awesome. Then we're going to get a little bit, more intimate for a little bit there. And Jim and I are going to have a bit of a fireside chat. We're going to talk about deployment challenges. We're going to talk about best practices. We're going to extract years of expertise out of Jim's brain in about 20 minutes. So, I can't wait for that session. Then I'm going to bring in Matt Starling from the Ekahau team. Matt is going to, go over the Ekahau portfolio suite and then talk about best practices in wireless design, as well as best practices in post-deployment validations using Ekahau technology. Then we're going to wrap it up at the end. So everyone, thank you so much for joining here, and let's get into it. And the CW, the Cisco Wireless Wi-Fi 7 launch, this is a journey. And it all started with this notion of let's bring Catalyst technology to the cloud. And this journey, I think, actually started years ago. I joined Cisco initially 10 years ago with the Meraki team. And it was in 2020 when we first started to bring some Catalyst capabilities into the Meraki cloud dashboard. There was some cool hardware like the MS390 based on the Cat9K hardware that we were able to then cloud manage that Catalyst hardware in a cloud platform. We also had some really awesome high density technologies like RxSOP, receive sensitivity startup packet, which is critical for high density wireless deployments. And we were able to deliver that technology in our Catalyst on-prem as well as our Meraki cloud portfolios. And so we started to see this cross-pollination of intellectual property. And this just isn't limited to the wireless and switching, this cross-pollination. We also started to see things like Talos threat intelligence come into the Meraki MX security appliance device. Moving forward into 2022, this was like a really cool moment because we did the Wi-Fi 6E co-launch. On the same day, we used the 9160
Uh, Jeff, I think we've lost your audio,
Yeah,
buddy.
with
We can't hear you, Jeff. And my lip reading skills aren't quite what they should be to be able to understand what you're saying.
And I thought it was me when my wife turned on the car and the audio switched.
Uh,
I hate when that happens.
But it looks like there's lots of people here in the chat joining from all over the world, which is amazing to see. So many people joining.
Thank you so much for dancing for me there. I hope I have my audio back. I got hit with the solar
yes, we
flare
can
here in
hear you.
DC.
Yes.
Oh my goodness. Okay. Well, we're back. So let's keep moving here. So in 2023, we then launched the Cisco C9300-M. This was a Cat 9K with a day zero Meraki experience. No longer this MS390 dedicated hardware, but now dual personality hardware transferable across both platforms. We also were able to bring in some additional cloud monitoring capabilities. So not the ability just to manage devices in the Meraki dashboard, but bring in more of the Catalyst portfolio for monitor only mode. We also started to see some cool IP being shared in a single central Cisco brain, releasing AI, artificial intelligence, RRM technologies across both the Meraki dashboard as well as Catalyst wireless portfolios. And then here we are today in 2024. Well, we're wrapping up the year, but man, this Wi-Fi 7 launch with the global universal access point onboarding experience, a single hardware device that's single SKU for global consumption, available on both on-prem and cloud platforms, and also a single license as well. Super exciting. We also did some other things as well in 2024 with cloud monitoring of the 9800, bringing all those Catalyst controllers into the Meraki cloud, making monitoring available through both on-prem and cloud platforms. We also just recently introduced Universal iOS XE on our switching platform. So a single iOS XE version that's available on Catalyst switches that can be consumed either in the Catalyst Center or in the Meraki dashboard platforms. And then, looking forward, let's kind of imagine, like, well, we have some things that are coming, but let's also kind of like imagine the opportunity in 2025. This opportunity of having cloud managed devices, but maybe local CLI configuration control. Let's also talk about expanding the portfolio of managed Catalyst hardware to the core, as well as our more cost-effective 9200L access switch platform. And let's talk about, let's imagine the opportunity when we have new tools in the cloud portfolio, like Meraki Campus, like the Meraki Campus Gateway, or even the new MX650, which we have betas going for both of those platforms. And then, before we wrap up the year, I want to have one what if. What if Cisco had not acquired Meraki? Or what if, actually even more scary, what if Cisco had acquired Meraki and completely abandoned our on-prem Catalyst portfolio? And so I just kind of want to leave you with some of those questions because, we're here now and it represents a long timeline and a long body of work. And we're really proud of this Wi-Fi 7 launch. And I'm going to be quiet now and I'm going to hand the ball over to Drew. And Drew, take it away.
Awesome, Jeff. Thank you so much. I'm just getting my ducks in a row here. So let me go ahead and get sharing. All right, can I get confirmation on the share view? Let's see.
We have audio, no slides.
No worries, no worries.
And we are golden, Drew.
We are
Let's
golden.
do this.
Thank you, Jeff. I appreciate it. So good morning again, everyone. Good afternoon, good evening for those of you who might be joining us late. It's not every day that we can introduce another chapter of Wi-Fi. I like to call these generations chapters because when you think about Wi-Fi over time, we've had so many chapters in our history of Wi-Fi. This year, we're celebrating 25 years of wireless with the introduction of AX11B that came back in 1999. And think about how much has changed over that 25-year period. So for myself at Cisco, I started 15 years ago. I was a TAC engineer back in the day, troubleshooting networks for best effort Wi-Fi connectivity. It was best effort back then. It was, I undock my laptop, I go to a conference room, I connect, right? I might have mission specific clinical use cases, manufacturing use cases, but they were few and far between. as things evolved over time, and I would argue over beers that in 2010, it was the iPad. When Apple came out with the iPad, there was no cellular connectivity, there was no wired NIC on that device, it was Wi-Fi only. And when that thing started coming to market, we saw digital transformation really happen start rapidly. More and more devices were connecting onto Wi-Fi than ever before, and people started treating Wi-Fi more like it was water than just a best effort convenience. Then, of course, we saw the Internet of Things, which we defined at Cisco. Originally, we said, hey, this is going to be a big deal, and it's going to come, and all these headless devices are going to start connecting, getting IP addresses, and they're going to be pulling down valuable RF space over Wi-Fi, and you're going to need to plan for that, right? We saw that happen. We saw machine-to-machine communication. And then, of course, the thing we didn't expect was the global pandemic that impacted the world, right? We all moved to a world where we started using streaming voice, video, and collaboration technologies. But then what surprised everybody was when we came back into the office. We came back into the office, some networks weren't up to snuff to be able to support streaming voice, video over collab technologies like WebEx, Teams, all these sorts of things out there that we start leveraging on a day-to-day basis. And we still do today, even on this very webinar, right? So this demand has changed, and as a result, Wi-Fi has kept up through the industry with various chapters. We're, of course, now at the 7th chapter with Wi-Fi 7, but what I want to do was just take a moment to look back at 6E, because there was a big introduction that came with Wi-Fi 6E that's the biggest change we've seen in the world of Wi-Fi in about 21 years, which was the addition of new spectrum. So historically speaking, if we go all the way back to 802.11a, is when we added new spectrum, 5 gigahertz, right? With Wi-Fi 6E, we added 6 gigahertz. 6 gigahertz is a big deal because it gives us a lot more capacity for us to operate on the network. So let's look at what that spectrum actually feels like. So when you look at a network that is before Wi-Fi 6E, so Wi-Fi 6 and prior, you were living in a box of 2.4 and 5 gigahertz globally. This was a box, this is the world of Wi-Fi as we knew it, right? It was a place where we would say, hey, all enterprise devices need to go to 5 gigahertz, best effort on 2.4, throw the guests there, whatever it may be, right? Then we introduced 6 gigahertz and created a one giant leap for connectivity. This is a huge change. 59 contiguous 20 megahertz wide channels available to us in the 1200 megahertz plan, and the 500 megahertz plan for others still gives you a lot of great channels to work with. But what it also does is creates a super highway of connectivity where all the net new devices connect and prefer 6 gigahertz or have the full capabilities on 6 gigahertz. The backwards compatibility issue that we've dealt with in the world of Wi-Fi still exists on 2.4 and 5 gigahertz. We still have to deal with the least common denominator, although they're dying fast, right? But on 6 gigahertz, it's all fresh spectrum for us to work with. A great place to be able to take full advantage of Wi-Fi 6 benefits, but also Wi-Fi 7. So I don't want this to go overlooked. I realize that most networks today are still running 2.4 and 5, and that's why we need to make sure that when we talk about, hey, the benefits of Wi-Fi 7, or why do I need to refresh my Wi-Fi? Well, it's really to adopt and take advantage of 6 gigahertz. And there's other things along the way, believe me, with Wi-Fi 7. So Wi-Fi 7 is a slew of features and capabilities and frankly acronyms within the spec that help improve throughput for clients, better packet delivery and reliability along the way with some other things. And what I'll do is I'll spend a few minutes diving into some of the key highlights that come out with Wi-Fi 7. So to start off, you can't have a new wireless generation with a little bit more data rates, with a little bit more throughput, FCS over-the-air data rate improvement. And we've done that with 4K QAM. So we can do 4096 QAM. Essentially, what we're able to do is pack a little bit more bits into those transmissions that come and go between a client and access point. And what that can do is give us a 20% aggregate increase in data rates when we compare it to the previous generation. Now, the reality is to get these data rates, you have to be a lot closer to the access point than before. And that's simply because of the high SNR that's required with having 4K QAM. Now, it's not all a problem whatsoever. In fact, an iPhone today that's running a Wi-Fi 7 chipset can get about 1.7 gigs per second on a 2 spatial stream 2x2 client, which is pretty impressive when you think about the actual throughput that you can now start pushing across a single smartphone. Now, the real technology that I think everybody's super excited about, if you've read up on Wi-Fi 7 at all or seen any other introductions to the technology, is around this technology that we call multi-link operation, or MLO. This is really a game changer in the way that we look at wireless connectivity today. So when you think about a device connecting to an access point, it connects on a single band historically. We would say, oh, we prefer 5 gigahertz. That's where I want my clients to go. And then I just told you 6 gigahertz, it's a new 5 gigahertz, right? But what if you could have that single client connect to multiple bands? So now I could connect to 5 gigahertz and 6 gigahertz, And look at that, I could start aggregating the throughput between both of those radios. So now I can potentially double my throughput if I connect at those two frequencies, or I could start steering traffic to pick my lowest latency link between maybe 5 and 6 gigahertz for my low latency application requirements. Lastly, maybe I can improve by redundancy. Maybe I want to make sure that, hey, if I get interference spikes on 5 gigahertz, I can still process 100% on 6 gigahertz and continue to deliver critical traffic. The best analogy I've seen lately for us networking nerds is this is a lot like an ether channel, the ability to have two links go to another switch and then channel the traffic across both to create resiliency as well as aggregation of throughput. And a similar thing is now being done with MLO. In fact, if you had a dual uplink access point delivering MLO to a client, I would make an argument and say, hey, that's a little more reliable than having a single wired uplink to a switch, because now I've got multiple bands to operate on. I've got multiple uplinks to my access point. There's something to be thought for that. So maybe that's another one over beers. In any event, let's look at the throughput over downlink throughput for a single MLO client versus a single link client. So when we look at that, we can see I've got a client that's running on 5 gigahertz as well as 6 gigahertz in MLO on just a 40 megahertz wide channel pair. So that's two 20 megahertz wide channels put together, not a big demand there from channel bonding. And I'm getting a gig per second of throughput. Now, when we look at the client on the bottom, it's a single link and it's 5 gigahertz, 40 megahertz by channel at 500 megs per second. But look at that. All we did was we took the 5 gig and the 6 gig, put it together, and we got about 1.9 times increase, or almost 2 times increase in throughput. That's going to be happening across all these devices that can support MLO and Wi-Fi 7 across the board. So something to plan for, but also something to kind of open up your mind and think, how are these devices connecting? This is pretty cool now that they're using multiple bands to connect on at a single time. Now, if this is kind of blown up your head and you're like, hey, this is different, this is interesting, then maybe this will give you a better way to look at it. So here's an example of the Meraki dashboard. And I've got two Wi-Fi 7 MLO enabled clients. I've got a Pixel as well as a Samsung connected to this platform. And you can see I zoomed in here for those that are squinting. You can see I've got radio 0 connected at 2.4 gigahertz and radio 1 is connected at 5 gigahertz on a single client. And then for my Samsung device, you can see the same thing, 2.4 gig and 6 gigahertz for a single client. And you can see the throughput numbers that we're pumping with that. So it's pretty powerful what MLO could do. And I'm really excited to see what it can do for Wi-Fi 8, 9, future specs. The world is our oyster when we start thinking about how one client can now connect on multiple radios. So when we look to the area of efficiency, how do we make things more efficient over Wi-Fi with Wi-Fi 7? Well, we had a challenge with interference in large bonded channel sets. When interference would come up on a large bonded set of channels, if we detected interference on one of those channels, oftentimes we'd have to let go of some unused channels because they were later on in that set. We'd have to drop those channels and they were wasted. And RF is a very precious resource. We don't get a lot of it. So as a result, what we can now do with preamble puncturing is we can say, okay, if we detect interference on one channel, we pull that single channel out of the channel bonded set and continue using all of the other channels in the set. It just makes us better, faster, stronger, and more consistent in the way that we go, and we don't waste channels along the way. Now, I mentioned that we can get some more throughput, right? Of course, you can get the better FCS data rates, you can get wider channel widths, and then MLO can give you more throughput. We can actually go to 320 megahertz wide channels. So if you look at 6 gigahertz as a whole, and you look at this chart here, this is the 6 gigahertz spread over the 1200 megahertz plan. We can get 320 megahertz wide channel sets all lined up there. Now, the reality is this isn't going to be used in home environment, or excuse me, it's not going to be used in enterprise environments, but more likely be used in your home environment to get these really high throughput tests, that sort of thing. But you can go really wide in channels if you wish, and that's totally up to you. But again, likely not enterprise environments, but what we are seeing are the prevalence of course, 40 megahertz, but 80 megahertz wide channel sets being used in 6 gigahertz because of the availability of spectrum, which is really nice to see. So we should take a moment to pause and think about security. So if you're familiar with Wi-Fi 6E at all, with Wi-Fi 6E on 6 gigahertz only, we require WPA3 and enhanced open. Those are mandatory. It was also mandatory to have protected management frames, or AO211W. That was previously optional. It's a really good thing to have these technologies. I mean, WPA3 up-levels our encryption game significantly, while protected management frames avoids man-in-the-middle attacks, which I was blown away was still a thing in Wi-Fi up until Wi-Fi 6E. The challenge, though, is that now with these requirements, and I should say that WPA3 is required across all three bands now, so 2.4, 5, and 6 gigahertz for Wi-Fi 7, is that you're going to have to start looking at your SSID configurations. So think about, how do I want to approach deploying WPA3? Do I want to have a pure play WPA3 SSID that supports 2, 4, 5, and 6? Or do I want to have a transition mode where I can still support my WPA2 clients, maintain my same SSID, and then also support WPA3 clients along the way? These are considerations as you start refreshing your network and deploying Wi-Fi 7 that you're going to want to pay attention to. So I talked a lot about the spec and what's coming with Wi-Fi 7, but of course, Jeff mentioned earlier, we've got some access points to talk about. So why don't we dive right into that? So at Cisco, we're always proud to say, hey, we go beyond the standard, right? We're going beyond what Wi-Fi 7 can deliver and actually do additional things, additional innovations that benefit everyone. One of those things is that we are now delivering one simplified product. And what that really means is that there is one product ID for every model of access point that's being released. So in this case, 3 at launch. There's only 3 product IDs. And these 3 product IDs can be leveraged globally around the world, regardless of the deployment method used. And I'll talk about that in a little bit more detail in a moment. We've also doubled down on resilient wireless. I talked earlier about this 25-year heritage of wireless and how things have evolved over time. And of course, everybody's had bumps along the ways. They've had missed expectations. They've had devices that were mission critical that were dropping from the network for various reasons, right? We realize that, hey, these things are mission critical. We have to have a closed loop process in the way that we look at wireless moving forward. So one thing that we do in wireless resiliency is have a series of vendor partnerships. And we started this many years ago, beginning with Apple, which later expanded to Microsoft, Samsung, and Intel, to make sure that from a development test perspective, we're working with clients before release. So we do dev test planning, we bench test everything, we make sure it works before release, we fix bugs, and we did a lot with Wi-Fi 7 prior to Wi-Fi 7 launch, especially regarding MLO. Then day 2, day 3 operations, we find that there are things that come up. Well, our support teams have a direct back channel to these other vendors that we work with, right, to make sure that Apple devices, Samsung devices, Intel devices all work best when running on a Cisco network. We've also added unique features and capabilities to make sure that analytics coming from those endpoints are delivered into the network, into your management purview, such that you can make meaningful decisions about the network, but then also about how the client performance is going along the way. Now, another key thing in this launch is Cisco Spaces. So we've enhanced new capabilities within these APs to better the experience with Cisco Spaces. If you haven't heard a bit about Spaces in a while, Spaces drives the next generation smart workspaces. So what we do is we build out a foundation using our Wi-Fi 7 access points, of course, high speed, mass capacity, etc. And then what we can do is create a map of the floor plans of your sites and locations. We can start managing IoT devices directly within Spaces and also bring in location context into your business information. So example would be Wi-Fi based location, Bluetooth based location, which is relatively new when you think about compared to Wi-Fi based location. And now with the Wi-Fi 7 access points, we're introducing ultra wideband or UWB. UWB allows us to get about 1 meter, sub 1 meter accuracy of the location of clients as they move across the floor. So if you have a UWB enabled endpoint made by major smartphone manufacturers or uniquely UWB endpoint, it can be tracked very, very accurately and with frequent updates, unlike what we could ever do before with Wi-Fi or BLE-based location. So it's a really wonderful location contextual data point that we can now integrate into Spaces. So great, you do all that. Well, what do you do with that data? Well, then you can start delivering outcomes. So one of which is that turnkey outcome that we have at Cisco, which is indoor wayfinding. Or maybe it's asset tracking. I need to track high value assets in my enterprise and see where those are located within sub 1 meter of accuracy. It's pretty cool that that's available. We also have occupancy metrics, real estate analytics, all sorts of things can be done within Spaces. So this is not just a limited list, it's just some examples. But then we also have our ecosystem partners. So if you're in a specific vertical, let's say healthcare and clinical environment, and I need to track specific things for that environment, well, we can directly plug into third-party partners and providers there in our ecosystem to be able to deliver the data from Spaces over to that third party. Now, pivoting back to the global use AP and that simplified one SKU, this is a really big deal for those of you globally who have been deploying access points and you've had a regulatory domain that's tied to a product ID. One of the challenges is that if I want to deploy into a certain country, I have to ship that access point to that country. If I wanted to ship it to an intermediate country along the way, maybe where I sit, I had to get export controls filled out, all sorts of nonsense, right, to get that all done. Well, thankfully, we've simplified that process drastically. So it's one SKU that can be deployed globally that will detect the regulatory domain for a particular access point. And there's several ways that we do that. We use GPS, we listen to the APs in the environment, we can use the Meraki dashboard, and if you're completely air-gapped, we can sneaker net a USB stick over to a wireless LAN controller to authorize APs. So we've thought about all the different scenarios. The engineering team has spent a lot of time on this global use AP concept. And it's not just Wi-Fi 7. This is going to go well beyond Wi-Fi 7. All future generations of APs at Cisco will have this flexibility. Before, we also had to have a different SKU, whether we wanted to use Meraki dashboard or if we wanted to use a 9800 wireless LAN controller optionally with Catalyst Center. And now what we can do is use just one SKU, and we can do the same level of detection on which management mode the AP should operate in. And we also provide seamless movement between management modes using our unified licensing that comes with the Wi-Fi 7 APs. All good things. Also, from a lifecycle perspective, you can spare these as many as you want, deploy them globally. You can RMA them. Let's say an AP fails, you simply drop in a new AP. Factory resets are also a cinch. So it's all simplified. I'm really happy that we've gotten to this point in our lifecycle of the APs. So when we look to the heritage of innovation for our access points, we have baked in everything we've done over the last 20, 30 years into these Wi-Fi 7 APs, which is awesome. We, over time, have developed features like flexible radio assignment, which allows us to switch an AP mode from 2.4 to 5 gigahertz or 5 gigahertz to 6 gigahertz. And that has given us a lot of flexibility in how we deploy APs for the demand of the network, but also the regulatory considerations of that country where the AP is deployed. We've also invested heavily in having dedicated silicon that's always listening for wireless events. And we've called that CleanAir Pro in the past, and that continues through the generation of these access points. And it provides us with dedicated AI and ML learning of our of our radios so that we can listen for Wi-Fi interference and also non-Wi-Fi interference. The same dedicated radio can listen for wireless security events using our WIPS feature set, which is a really powerful thing that continuously scans for any wireless security event that we want to that we're not planning for. We also, of course, have a 2.4 gigahertz radio that's able to provide BLE, transmit, and receive. And now, more recently, we've added in this ultra wideband radio for that sub 1 meter of accuracy. There's a lot there. You can see GPS is included now, as well as GNSS globally is what we commonly know it as. And putting all those features together, or capabilities together, we can now use AP auto locate. So one feature that we have now is the ability to automatically place APs onto a floor plan, whether it's Meraki dashboard or Catalyst Center, and then deliver that using UWB as well as GPS or GNSS is more known globally. Lastly, these APs now support up to 10 gigabits per second of multi-gigabit Ethernet. So about 8 years ago, I remember talking about the $250 million that Cisco had invested in this thing called MGig. And nobody wanted to hear it because they were all like, I just got gig ports, it's all good. But I told you, you have to plan for this. This is a journey, right? And MGig is a reality now with these APs. So MGig's a big deal. We, of course, have multi-gigabit Ethernet. We invested a bunch. We developed it. We launched it. It's now in the NBASE-T Alliance. It's now an industry standard across the board. But essentially, all these access points, because of all the throughput that I talked about earlier, are going to require more than 1 gig to be optimal, to be able to achieve everything that you want to achieve with the APs. So speaking of APs, here they are. So we operate at releasing the top end of our Wi-Fi portfolio at Cisco. So these are our best-in-class access points. You're looking at the 9176 as well as the 9178. So the 9176 is the replacement to the prior generation, the 9166 if you're familiar, or you can think of the previous 2K APs, so 2600, 2700, 2800 in the Catalyst world. On the 9178 side, well, that's our best in class. So that replaces the 9136, the MR57. It also replaces the 3K series access points, so 3600, 37, 3800, and 4800. These guys all, of course, have 10 gigs of multi-gigabit Ethernet. The 9178 has dual 10 gig uplinks. We also have ultra wideband as a new inclusion to the portfolio, and I'll spend a little bit of time going into more detail with each of these access points. So the 9178 has a hexa radio architecture. The idea behind that is we've got one radio that serves 2.4, we've got a 5 gigahertz radio, and then we have another 5 gigahertz radio. So dual 5 gigahertz radio capability on this AP while also delivering 6 gigahertz dedicated client access. Then we've got the scanning radio. So our client serving radios serve all the time, and then our dedicated scanning radio is there scanning all the time for wireless security events, non-Wi-Fi interference events, all the things I warned you about earlier. Our IoT radio is delivering BLE today, and it's programmable for the future for other 2.4 gigahertz technologies. Then we look to the uplink to the access point. I mentioned that you can do dual uplinks, right? So we can have dual Ethernet, dual multi-gig, up to 10 gigs per second for both PoE and link redundancy. And again, unless it wasn't abundantly clear, these APs work on both the wireless LAN controllers as well as on the Meraki dashboard. Now here's the 9176. So this AP is the slightly slimmed down version to the 9178, but it's awesome on its own. The big difference between the 9178 and the 9176 is the dual uplink capability. So it's just a single 10 gig uplink to this access point, and then also the dual 5 gigahertz dedicated capability. You can do dual 5 gigahertz on 9176, but you would use the XOR radio that's in the 2.4 gigahertz radio. So 2.4 would then cut over to 5 gigahertz. But other than that, same silicon, same chipsets, a great access point that's available to us. Now, one thing I didn't mention is that the 9176 comes in two flavors. So you've got the omnidirectional flavor, and then you've got the directional flavor. So just to go back in RF physics and thinking about the propagation of RF, if you've got Omni, you stick it up on the ceiling, it lights up a room, right? It gives a nice clean coverage. For a directional, if you put it on a wall, you point down with our nice articulating mount, we can light up a wall like a flashlight can. Directional antennas are really helpful in the world of areas where you might have an auditorium, a high density space, an atrium with really large ceilings, a warehouse space, manufacturing. That's oftentimes where we have really high ceilings, we need to get a better shot. And I know Jim has such history in this, I'm sure he'll expand more on the benefits of directional versus omnidirectional in the conversation upcoming. Now, as far as hardware is concerned and software, well, the 9800 controllers are the only WLCs supported, and you can see all the models, of course, all models are supportive of the 9800, but will require 1715.2 or later. And then on the Meraki dashboard, it's as easy as having R31.2, and the APs will be off to the races. So I mentioned throughput, I mentioned power. There's going to be some impact to the switching network, right? There's some things that we need to think about. And one big takeaway from this discussion is I want to make sure that you know the benefits of Wi-Fi 7, but also the implications to the wired infrastructure, and begin planning now. Because we all know that wired and wireless refreshes of equipment never happen in sync. I mean, sometimes they do for a new site or deployment, but oftentimes you're refreshing the wireless or you're refreshing the wired separately. So it's really important to know the requirements of Wi-Fi 7 in the switching layer to make sure that we plan accordingly. So the bottom line is, hey, more advanced Wi-Fi requires more processing, which is going to suck more power. We've been growing and changing over so many years to add UWB, to add GPS, to add the radios, to add the MGig, which is very power consuming, to our APs. We're going beyond 30 watts of power to get the full capability of the access points. 30 watts of power, if you're doing your math right, that's PoE plus. So historically, we've been able to operate on PoE plus with all access points, for many, many years. Now we're entering a world where UPoE is now the preferred grade of power over Ethernet for access points. So for these Wi-Fi 7 access points, for them to work at optimal state, full power, all radios, all the capabilities I talked about, we require UPoE. Now, here's a good history lesson on PoE if you haven't studied on it lately. There was old school PoE, which was up to 15.4 watts. I mean, I remember talking about 1131s on 15.4, 1010 APs, if you remember those. Times have changed, right? So PoE plus 30 watts is where we were operating for a long time. That's where we are today, a lot of networks. UPoE is now the gold standard for Wi-Fi moving forward, or UPoE plus, of course, if you're going to do 90 watts of power. But that gives us enough power to meet the demands of today with Wi-Fi 7 APs and then APs into the future as well. Now, our APs will absolutely operate on PoE+. They're just going to be in a slightly degraded mode. So this is the fixed power profile example for a 9178. You can see essentially what happens is we pull back on spatial streams, the transmit receive chains, a few things on the AP. The multi-gig performance gets pulled back a little bit. So we can make it work with PoE+. So don't be alarmed, because you can't say, hey, Drew, I can't refresh everything at once. We all realize this is a journey, right? So we want to make sure that we can meet the demands of what you have today. This is an example of the 9176. We pull back a little bit on the 2.4 gig radio, pull back on MGig, so you can see that. The bottom line is this is the default fixed power profile. There's also a power profiles feature on the 9800 controller, which allows you to have some ability to change. Do I want to disable this radio to make up for the loss there so I can get in my PoE plus budget? But the bottom line is to be optimal with our Wi-Fi 7 APs, you'd want to adopt UPoE for those switchboards. Now, the other consideration outside of power is all about throughput. So we talked about the generations and chapters of Wi-Fi and how these have evolved over time. Well, with each generation, we saw an increase in throughput to clients. And now we're getting to that place where we've got MLO, we've got 6 gigahertz. We actually can begin delivering these high throughput experiences. As a result, it's pushing us beyond that 1 gig uplink. And that's where multi-gigabit Ethernet is so critically important. So our recommendation would be to connect these APs to multi-gigabit Ethernet ports up to 10 gigs per second. So this Wi-Fi 7 APs can provide 10 gigs per second. The MGig switchboards can provide 10 gigs per second. And this can be negotiated down from 10 gigs to 5 to 2.5 and 1 gig. Now, one key consideration, this is something that we haven't had to look at in a while, is what category of cabling are you running in your plant? So is it Cat5e, is it Cat6, Cat6a, Cat7, beyond? There's some considerations for MGig with Cat5e. It's not supported at 10 gigs per second. And then Cat6 is limited to 55 meters instead of the 100 meters for 10 gigs per second. But for 5 gigs per second, it can go the full distance. So just know that there's some cabling considerations with regard to multi-gigabit Ethernet. But at the end of the day, just know that if I want to be optimal on Wi-Fi 7 APs, it's UPoE with MGig is the combination that will make you successful. Now, when we think about switching and potentially refreshing legacy switching, maybe this is a good, put in the pros column. If I refresh my switch, I can get the benefits of being Wi-Fi 7 ready. Well, you may also want to rethink the way that you manage the network today. You might be using CLI to configure your switch with a notepad with your saved template, right? Or maybe you're doing something a little bit more advanced, but you get the idea. Consider using Meraki Dashboard. You could have your Catalyst switches managed in Dashboard, as Jeff mentioned earlier. You could do something in between with Cloud Connected, where you've got a switch that's still running CLI, but can be cloud connected to the dashboard. So we get full visibility in single pane with the rest of Meraki infrastructure. Now, if you're fully on-prem, you can absolutely continue using Catalyst Center. And you've got that to manage your switching. You can do plug and play automation, day 0 to end of life automation there. So just think, as I am refreshing, think about wireless, I'm refreshing switching potentially because of the requirements there. Well, maybe I should consider how I manage my network. And of course, we are more than happy as your account teams to help you, figure out that journey for you. So with that, I don't know about you guys, but I'm excited about Wi-Fi 7. The technology is awesome. 6 gigahertz, I'm still excited about it, even though that was a 6E thing. It's going to be mainstream in Wi-Fi 7. MLO is going to be huge for us. And of course, the considerations for the wired network. I kind of like to see, as a wireless guy, the Wi-Fi network driving the need for more bandwidth and considerations on the wired side. It's all good to see. And with that, Jeff, I'll hand it back over to you.
Awesome, Drew. Tremendous update there. Wow, that was probably an hour of content you delivered in about 30 minutes.
My pleasure.
Yes, we will absolutely share these slides after. We're going to share this recording out after. Share it with your friends after this event, because this is a lot of great stuff that's coming in here. So Drew, before you leave, so that MLO that you showed, so that client was simultaneously connected on 2 different spectrums passing traffic 1 gigabit per second. That's phenomenal. I mean, that was awesome. Well, okay? So my question for you, Drew, what is your favorite Wi-Fi 7 feature that Cisco delivered?
It's funny. I keep telling, I tell everybody it's 6 gigahertz, but technically 6 gigahertz was the previous generation. So I would say MLO, of course, is the best feature. I was speaking with a customer yesterday, a manufacturing customer. They had Chromebooks deployed for their factory warehouses. They told me, hey, we're moving to the next generation iPad for operations. It already has a Wi-Fi 7 adapter in it that supports MLO. Immediately, our conversation shifted from being an old factory floor to, hey, how do I deliver Wi-Fi 7 with MLO successfully because of that value? So I'm already seeing the value, and I was surprised to see that so quickly. So yeah, genuinely, I think MLO will change things for us.
Super cool stuff, man. Drew, thank you so much. Really appreciate your time, your preparation here. And Drew's going to be in the chat space. If you guys have any questions in the Q&A, throw it. We got Carlos in there. We got the whole team answering questions. So, Drew, thank you so much.
Of course, thanks.
Now, Jim Florrick, you are summoned to join the panel.
I shall appear, sir. Good stuff, Drew.
Awesome. Yeah, great presentation. All right, Jim. Well, let's start by why don't you introduce yourself? Tell us a little about what you do here at Cisco, and maybe a little bit about who Jim Florrick is.
Okay, thank you very much. I am Jim Florwick. I'm a principal technical marketing engineer with Cisco Systems. I've been here for almost 18 years now. My background, I came from spectrum analysis at a time when Wi-Fi was a treacherous place to live, and everybody heard, but we have to use all three channels in 2.4 gigahertz. It was a questionable time. So tools was important, gave me a good start on the Wi-Fi side of it. And I'd flipped over to wireless a couple of years before that, came to Cisco, and first product was RRM and never looked back. I've gotten plenty of great opportunities to install some very large networks with Cisco and learn a great deal in the process. So it's been a journey, and Wi-Fi 7 is an amazing protocol to introduce into this. Talking as somebody who's done everything there can be done wrong in wireless, this is really right steps we're making now. So
yeah, we've all made a few mistakes in our deployments. I remember my first 11B network I deployed. It made sense to put all of the APs on full power on channel 6, right?
of course it does. Yep.
At the time, yeah, that was a lot of trips up the ladder.
Platforms are right.
All right, Jim. So I guess I got a few questions for you. So the first one is going to be around automated frequency coordination. So Wi-Fi 6E launched without AFC, and this really limited our ability to leverage external antennas and do outdoor deployments with 6 gigahertz.
Yeah.
But AFC ratification happened this year. So what are the benefits of AFC? What did this deliver? And then what have you seen in practical challenges of deploying AFC?
Well, so first off, the US LPI rules, the initial ones were written a little differently than most of ETSI or the regions that got just Uni 5 spectrum. In the US, we got 1200 megahertz, and the potential for interfering in that wide of bandwidth was much higher. So for the low power indoor rules, we got capped at 18 dBm. One thing we did that was nice was add that additional 3 dB of power every time we double a bandwidth. That automatically gets kicked in, and a lot of people don't know every time you double the bandwidth in 5 gigahertz, you lost 3 dB of SNR. So it made up for that all the way up to 80. When it really sunk into me was when we started looking at AFC and why I'd want AFC power, was the point that in LPI at 20 megahertz, which is where all of your management traffic will be sent, you're limited to 18 dBm of EIRP power, period. So even if I'm doing 27, dBm out there with an 80 megahertz channel, I'm not going to get that at 20 megahertz, and that 18 dBm defines my cell boundary forever in LPI in the US and definitely in Canada, because we're bringing AFC online in Canada right now. So I got a host of manufacturing that's really looking forward to this coming on board. Now, AFC is, you asked most folks, if they're happy about handing their Wi-Fi network over to control by a government database, and you start to find people losing their appetite pretty quickly. But this is not new. AFC really is kind of like CBRS. We're mapping all of the data we have for the FCC. We know all the license holders. In fact, in the US, it's fairly easy. If you know a location, you can do a search on the license database and find out where the stations are, powers, frequencies of operation. So there's a lot of data available. Their job is to just keep us from getting into the incumbents. And there's a lot of serious users that still have a lot of 6 gigahertz investment out there. And outdoor was controlled very, very carefully because, well, of course, the higher you go, the further the signal goes. And you can get into these guys pretty quickly. So as time's gone on, there's been some challenges with the way that was placed, and I do see further change coming to the AFC rules. We're working on it constantly with government affairs over here. Just,
mean,
you know, little
AFC
things.
seems to make a lot more sense to have some predetermined coordination of spectrum versus something like DFS, which is, you know,
makes
you can
it-
operate, but then you have to immediately back off.
Right.
So it seems like a little bit more thoughtful, predictable way to deliver the
And
spectrum.
it's not nearly as bad. It's every 24 hours. We don't see a lot of variation in the database. We've been watching it. We've been talking to the AFC for a couple of years now. Maybe 5% variation, you know, across the country over the course of a year. So it's worked out really well. Challenges to it, GNSS. You got to get a GNSS deployed. And honestly, when I first took one of these APs home, I thought, no, there's no way you're getting GNSS indoors. We all know you're not getting GNSS indoors, right? Everybody
Mhm.
knows it. But I did buy a decent Garmin GNSS, which was my prize for me. But started walking around carrying it with me everywhere inside of buildings and seeing what I could see of satellites with just a handheld unit. And I was pleasantly surprised. With the APs themselves, we ran through and did some testing. I've got a deployment guide that we kind of just put out there quickie where we placed it. I had one AP that was 10 meters from a window on the second floor in building 24 in San Jose. And it would only see 2 satellites, and it wasn't enough signal to qualify either one of those as good. All we did was plug in the external antenna. We didn't even extend it. It was right at the ceiling level, so we didn't give it better angles to the window or anything. And I got 16 satellites in a lockup. So it's not as bad as you'd think. We do have a building that is an E building, SFO. And boy, if you got an E building, you're not getting a GNSS signal inside of that building. But you've had to bring other signals in because of the same thing. So you've got a repeater system. You will have to probably penetrate and get an antenna outside. Other than that, there's some logistics. You've got to distribute that signal. We've made it pretty easy. You can do it over a switch. You can do it over the air. Both stacks do it very well. In practice, it's not terrible to manage. We had a couple of surprises. Water negates all losses. So if you hit water, anything at 6 gigahertz on the other side of the water gets propagated pretty directly. So we did have one location that we couldn't get the air levels down or the uncertainty down. But it's there, it's a tool. And for the folks that are using it, it gives us plenty of spectrum that's usable. Now I see it large public venues, getting to the ground, warehouses.
Yeah.
66E1 works just fine.
Yes, that's interesting. And remember, like for everyone out there, you know, 3 dBm increase is almost that's 2x the transmit power, correct? Out of the radio.
Yeah.
And so being limited at that LPI at 18, going to 21, going to 24, turning that up, which is really going to unlock some wireless use cases. Yeah.
Right. It really benefits the throughput. Getting beyond that 18 megabit per second barrier is definitely what you need when the ceiling gets higher, right? So you'll be able to put more power down and get bigger cells when the ceiling's too far.
We're not like AFC. We're gonna move on a little bit here. So we're beyond low power. We're using standard power, but for so many of people I've worked with, we can't even use 6 gigahertz because we're just not ready from a security perspective. So WPA3, like, should we care about it? Should we just, rely on WPA2? Like, what is it? Should we be doing it?
You should make friends with it. You should definitely make friends with it. It's not going away, and everything is gated to it right now. Unless I've got WPA3 enabled on all of my SSIDs, I'm not going to do MLO across those SSIDs. So there's no 11BE features unless you're doing WPA3. And let's be clear, there's two concerns. Back when WPA3 was first released in 2018, there was a transition mode that was offered then, and we found clients were just puking on it and unhappy. So there may be some bad experience out there with WPA3. What's really changed is when we went into 6E or to the 6 gigahertz band, PMF went away from being optional to being mandatory. And now that has caused some hiccups with some clients. Now we've been doing some testing fairly regularly, and most modern clients are handling transition mode quite well. And we've got We've got some practical examples in the wild right now, so I'm starting to feel a lot better about that. But that transition mode, if you lock it up on one SSID, you're only going to get one SSID, and you're missing out on MLO, which is a huge benefit. And keep in mind that might be fine. We'll just put our Wi-Fi 7 clients over there. But getting those guys out of the spectrum that everybody else is in, meaning you give them MLO, you give them, perhaps you get the 4K QAM and you get those off the air faster. Every one of those that gets off the air faster leaves more bandwidth for everybody else. So it's definitely something that it's not going away. I think you're going to find more and more features needing to be unlocked by the use of WPA3. I recommend getting familiar with it and understanding where your organization is. We've all got those clients nobody wants to buy again, but at a certain point, you just can't keep running a golf cart on an F1 track.
That would slow everyone down. And
It
just for
does.
everyone out there, PMF, protected management frames.
Yes.
What is that between the client all the way to the Radius server? We're going to be doing
Yeah.
this encryption. Oh, that's tremendous. It seems like it's going to make our environments less vulnerable to man in the middle or other attacks as well.
We all hate it when we've got to do more security, but boy, you need it these days. You really do.
All right. So let's keep moving through here. So as Cisco, we've been using AI in our wireless since the beginning of RRM. I mean,
Yeah.
Jim, I bet like some of that AI was probably your intelligence that we've imbued into this into our tech stack over time. Yeah, don't blush.
Are you
so-
happy with it? Because yes.
Man, I never had to go up a ladder to change the channel on an AP once we introduced auto RF technologies, RRM technologies. So that was definitely transformative from a Wi-Fi deployment perspective.
Yeah.
But now recently, Cisco has supercharged our AI capabilities. So what is the relevance of AI in wireless networking, going into 2025?
Well, you just mentioned it right there. You haven't had to go up a ladder in a while. I still know people that do manual channel and power plans because they like to do it on a spreadsheet. They're the rare person. You just don't have time to do that. You add in things like AFC, my available channels that I can use on a given AP may actually change. So dynamic has to be there. What really changed with the AI was the ability to do trend analysis. And in any live system, you are reacting to what you're seeing over the air. However, you're collecting that neighbor information or understanding the local neighborhood around you. It's either coming from beacons or it's coming from some sort of neighbor discovery protocol. When you see those changes, the idea is to react to it, right? You don't want to be overly reactive because then you start flopping channels all over the place. During the daytime, you want to damp it down, and you actually, it's most of the time what you find is that the changes that need to be made are reactive and in that moment. And if you dampen it down during the daytime, then you're using what's on the air whenever you allow those changes to happen, and you're suboptimal for the network. AI, because it learns from that, large model, first off, all of our algorithms really haven't changed much in AI. What they've taken into account is that trend analysis, and then the things we can do, like calculating busy hour and making recommendations on when the best time to do an update or make changes is. We can defer changes that we see during the daytime. We can dampen changes and make sure that the environment stays stable during the daytime. And then take that learning on what would be optimal and apply that in the after hours or off-peak times based on the network's schedule. And we can do this. We can roll out changes across AP so that we don't do massive changes to any one neighborhood at one time. In fact, that's the way it goes out. So that trend has something that's always been wanted. I've got mind maps that go back to 2012 saying, geez, if we could just do this. It turns out that's a lot of data, and big data and the ability to analyze that data and everything that goes with it is exactly what we get with AI enhanced now. And it's just getting smarter. It's actually surprised me. The complexities that we used to deal with our profiles and everything else has been simplified. I was doubtful in some areas where we had a lot of those changes. I will tell anybody now, I recommend dialing that back out, starting with a base function and letting it be analyzed. So
All right, awesome. And then all of this
AI is
AI
going to
knowledge.
get smart. I'm training my replacement, Jeff. That's what I'm telling you.
Well, you've served your time, Jim, but I don't think we're quite ready to let you go quite yet, man.
Well, I
Uh,
hope to stick around and
all
enjoy
right.
it for a little longer.
Um, now let's talk quickly about using AI to troubleshoot issues. So intelligent PCAPs. What is this concept? Like, how can it be used?
Well, intelligent PCAPs is going to just trigger a PCAP on any anomaly, roaming analysis, joins, bad clients. It's a tremendous thing because the first thing, well, you always have somebody call up and they say, oh, last Wednesday I was in the cafeteria and the connection got a little flaky, and it's like, well, let me dial up my Wayback Machine and go back to last Wednesday. And particularly for a client issue that I'm going to end up sitting out there with a PCAP for, an hour if I can get you to come by and see if we can get it to do it again, right? And it's usually a combination of things that make those opportunistic ones go bad. That's the beauty of the intelligent PCAP. I can trigger it. I can trigger it on your client. I can pick a VIP. I can say, look, this guy's having a tough time on my network. I want to see what happens and why things are bad, right? So it's just about developing intelligence when it's in the network. And it's a tremendous feature. It really is.
Jim, we've
Yeah,
all been there where the call comes in and, well, the wireless issue isn't happening right now,
of
but
course not.
last Wednesday.
Yeah,
So yeah, having the system do that packet capture, trigger that based on the event log event that happened when the user experienced the issue,
yeah.
and then be able to use the AI in the cloud to have some easy analysis of that. That seems like a lot of that step one triage that we're doing for wireless issues. That's gonna be very powerful. Certainly recommend everyone gets in there and turns that on in their platforms.
Absolutely.
All right, Jim, last question for you. So this new radio that we've added, not the GNS or GPS one, we talked about that one, ultra wideband radio.
Ah.
Why is UWB so cool? Like, tell us about FTM. Like, this is exciting.
So
This is a whole new world for Cisco here.
when I entered Wi-Fi, we had the location wars, as I like to call them, going on between Cisco, Aruba, Meru. I mean, everybody was 1 meter accuracy, 3 meter accuracy. We all got better later. I mean, if you got 1 meter accuracy, it was cherry picked,
Hmm.
because there were so many factors that got involved. 3 meters accuracy was pretty good. One of the problems has been that all methods so far of how we locate things over radio have flaws or have, corner cases that aren't particularly good with them. UWB, because it's such a wide band of frequency, gets so many data points at different frequencies that it's able to correlate. What I will tell you is in a congested environment, I saw this. It was Mobile World Congress last year on the show floor. FTM was having trouble getting on the air, but UWB was doing good. Now that was a problem with FTM, but it did kind of back it down the busier the air got with high channel utilization, which made perfect sense. UWB stomps through it, and with the accuracy that I've never seen from a location solution, it really changes the game. There's some considerations to deploying it, depending on whether you're doing client-based or you're doing network-based. Depends on which direction the location is going, but there's a lot of flexibility in there. Thing I'm most excited about is I got them all now. I got,
Hmm.
Wi-Fi, BLE, FTM. I can positively locate the APs, which was the biggest. We had hyperlocation at one point in time. Biggest challenge with that was getting somebody to point the arrows all in the same direction, right? And the accuracy of getting that AP on the ceiling. So we're overcoming a lot of that. Right now, I can take an Ekahau design, I can put it into a DNA server. I can bring up that floor plan with the APs where they're placed, run FTM and AP out to locate, and DNAC will come back and tell me which APs are not where I intended them to be, or if I've got two serial numbers swapped. So it just takes a lot of the have to go on site and put an eyeball on it jobs off the table, which is good.
Very cool. So yeah, not just relevant in post-deployment location
No,
applications, but in the actual
day
deployment
zero,
themselves as a
day,
as a checksum of sort to make sure.
day
That's
zero.
super cool, man.
Yeah, we
Well,
spent
Jim,
3, 4 days setting up a Cisco Live to get that whole hall up and running, and I guarantee you, every year there's an AP we can't locate. We know it's on the network, but we can't physically locate it.
it's out there
Not for
somewhere.
days. It gets put on the map wrong, and you just can't find it.
Definitely have had that happen once or twice before. And Jim,
Yeah.
I could sit here and talk with you for hours, but I think your
You got a
last
lot of
one,
people.
we had the we have 175 people joining us today. So man, I hope everyone is
Great
enjoying this as much
broadcast.
as I am.
Hey, thanks for putting this on. I'm sitting back intently listening.
All right. Well, I feel like your last answer there, Jim, was a perfect segue into our last, but certainly not our least relevant guest of today. Matt, are you out there? Are you hanging out with us still? I know it's late night in the UK.
Yeah, I'm still here, and I would
Here,
maybe
Jim.
argue that I could be the least relevant guest on today because I've been sitting back and enjoying the content a lot, just like everybody else in the chat.
Well, awesome. Well, Matt, thank you so much for sponsoring this event today. Really appreciate everything Ekahau does with Cisco, from the entire life cycle of wireless deployments, from plan, design, and then the validation afterwards. So, like, what have you guys been working on over there? I know you have some cool new tools that you want to share.
Yeah, so you guys have been talking so much about your new Wi-Fi 7 access points and how cool they look. And we've got a new online solution to our main design and analysis software called AI Pro Online. And I'm going to be able to show everybody on the webinar today what the actual coverage looks like coming from these new Wi-Fi 7 access points, including the D1, which is really exciting for me because if I think about when you need to design for Wi-Fi best practices in challenging environments such as warehouses, large public venues and stuff like that, especially when you're talking to Jim around the challenge with 6 gigahertz and the outdoors and AFC and external antennas, the fact that you integrated a directional antenna now means that you can deploy Wi-Fi into these venues such as warehouses with long racking aisles and the large public venues when you've got really high capacity requirements and you need to carve up that spectrum and to be able to allocate that frequency around. So it's been a great solution to be able to use for a few deployments, and I love seeing them around. And I'm really excited to show everyone actually how it looks like in our tool and then see those beautiful heat maps coming from the access points.
Awesome. Well, let's see if we're actually sending some 6 gigahertz signals off these new devices that we're pushing here.
Okay, awesome. Well, let me share my screen, and hopefully if I move that there, you see everything okay,
And we
Jeff?
got you, Matt. Yep, we got you.
Awesome. Okay. Well, before I jump into some live demos, I don't know if everybody is aware that actually Ekahau is a part of Ookla, and inside of Ookla sits a few different brands. I think one of the ones that you might have heard of is Speedtest. I know personally I run quite a lot of speed tests per day. So I'm trying to see, is there a way I can just get the chat back open actually? Because I did have a question I wanted to ask people. How many speed tests on average do you think are run per day globally? And I'm gonna wait till I see some answers in the chat before I actually answer this. So yeah, how many speed tests do you think run per day on average? Let's see what some of the people are saying.
Millions, billions, and trillions, Matt. Somewhere in the between, I'm sure.
Yeah, I couldn't believe it either when I found out actually on average there's 11 million speed tests run per day. So that's an insane amount of data that is collected with speed tests. So yeah, that was pretty crazy, blew my mind a bit. So yeah, Ookla sits speed test, Ekahau, Downsdetector, and another company called RootMetrics. And the reason why I wanted to bring that up briefly is because there's going to be a massive benefit for our combined customers, because now when you combine these tools together and you're going to be able to get so much more data, which ultimately is going to give you a better performing network. When you have an insight into not only how is your Wi-Fi performing, but also monitoring how good is your throughput, your ISP, your bandwidth. Sometimes you're wondering, oh, hold on a second, is it me that's having a problem, or is it maybe the service that I'm trying to get to with Downsdetector? Like, for example, I don't know, WhatsApp is down, or is it a problem that I have, or the DNS server? So ultimately, that level of insight into the whole throughput of your network is going to be so helpful for you as our customers. So I don't know if everyone is aware of that, and I wanted to make everyone aware. But moving on to Wi-Fi 7, which is the topic of today. With Ekahau, you actually have kind of two paths towards a Wi-Fi 7 network design, either upgrading an existing Wi-Fi network that you may already have out there that could be just 2.4 and 5 gigahertz, and you can do a redesign. And what we can actually do is leverage measured survey data to redesign your network. And I guess with the hundreds of people that are on the call today, you've probably deployed or managed a Wi-Fi network in your time, or will do in the future. I know for me personally, when I was deploying lots of Cisco wireless networks back in the days before I joined Ekahau, whenever I was having that conversation with a customer around an update to a new design, or when another access point would come out, one of the first questions would be in that initial kind of conversation would be, so Matt, we've got these brand new Wi-Fi 7 access points. We've obviously got all these access points currently deployed in our network. Is there any way that we can just take down these old access points and put up these new ones, and the Wi-Fi is going to work really well and meet all of our requirements that we need? You're shaking your head, Jeff. I guess you might have had this
Making me
question
nervous
once or
here, giving me PTSD, Matt.
twice. So that, but before though, when people would ask me that question, I would look at them and I'd go, maybe. There's a lot of caveats here. There's a lot of things that could make it work. There's a lot of things that could make it not work. We really need to understand your environment, and there's lots of other questions. But why I'm bringing it up is because with the measured data design, we can simulate that rip and replace scenario leveraging existing survey data. So it could be a survey that you captured back a year ago, 2 years ago. When you import into AI Pro Online, you can actually swap out all of your old APs for brand new Wi-Fi 7 access points, and then see the coverage and the different requirements to see if it will meet the way you want the Wi-Fi to perform, or if you need to tweak a few things, add an AP here, move an AP there, that kind of stuff. Then on the right-hand side, we still have our traditional predictive modeling methods where you can just upload a floor plan, you set a scale, you draw your walls, your obstacles, and you place your simulated access points. And then you can then see the predicted coverage coming from those access points. But at some point in time, you will need to go and do a Wi-Fi survey to understand your environment, because it's really key to know like what is the physical from your physical materials you have, like what is the attenuation. You can make assumptions, but I've been there before when I've got it wrong. I've assumed a drywall was 3 dBs, and actually I didn't realize there was the concrete wall in between. So it went drywall, concrete wall, drywall, and that's a big difference between 3 dBs of a drywall to almost like 15, 16 dBs of loss there. So you really don't want to get caught out by that kind of thing. And also as well, with the conversation with Drew, Jeff, and Jim talking about Wi-Fi 7 SSIDs and the configurations, it sounds like we might be turning on 2.4 gigahertz again, and having the same SSID across multiple frequency bands. Therefore, we now need to understand like what is our RF environment like? Do we have lots of interference on 2.4 gigahertz? Do we have channel availability on 5 gigahertz? Have we got lots of noisy neighbors? That kind of stuff. So it really is beneficial to go on site, understand your physical environment, where you can calm out access points, and also your RF environment, find interferers, understand how RF is going to propagate, and then use that data to design an accurate Wi-Fi network. So that being said, I really just want to spend most of my time today with you all wonderful people doing live demos. So the first thing I want to show you is this is a survey of a lovely office that I visited recently in Paris, probably the nicest office I have ever been to in my life. You could look it up on YouTube and find a nice tour of inside the office. It's really, really nice. I would recommend it. And whilst I was there presenting at Cisco for a demystifying Wi-Fi event, of course, I don't go anywhere without my sidekick too, so I had to do a survey. So what you're looking at right now is our AI Pro desktop application. The reason why I'm actually highlighting this to you first is because with the desktop solution, if I wanted to, simulate, I can see the coverage coming from these access points. But if I wanted to, simulate moving an access point or adding an access point, or swapping out these APs for new ones, what I would need to do is actually draw all of the walls. I'd have to draw all of the obstacles. I would have to make sure I've got all of the attenuation values right, and then I could place simulated APs. And for example, if I move this access points over here, what you'll notice is that the heat map doesn't change, because this is just purely just looking at the measured data and shows that to you, unless you build a simulation. So even if I move this around and put this back, nothing updates or changes here. So let me show you our AI Pro Online software. And can I put that down? Perfect. So this is the exact same file. So what we was just looking at, but now we're in our AI Pro Online software. And again, I've not drawn any walls or any obstacles or anything like that. This is just that live measured survey data. And I can see the access point here, the coverage coming from the AP. The other thing I want to draw your attention to is down here is we currently just have 2.4 and 5 gigahertz. So we haven't upgraded to 6 gigahertz yet. So this is something that we can actually simulate now and see if keeping the existing AP locations, upgrading to a 6 gigahertz Wi-Fi 7 model access point, will meet the requirements. So the other thing that I can do is if I wanted to simulate now moving this access point, I can actually just move it around. And what we do is we use your measured survey data and an AI and machine learning environment in your space in our online software, so we know how RF propagates. So that's why we can do all of this complex calculations and show you how making these changes is going to impact your space, even without you having to draw kind of any walls or any obstacles, and it's super fast. So what I want to do is actually simulate swapping all of these access points here. So I'm just going to grab all of the access points, and why don't we change first of all to the 9176i model. So I'm just going to simply click on it, and what you'll notice straight away, well, what it will happen instantly, but you'll see that we will now get access to visualizing 6 gigahertz. And if I turn on the channels, you can see we've got the nice orange for our Wi-Fi 7 icons. And if I go to here, you can see now we've got 6 gigahertz coverage being displayed to us. So if I just zoom in, I can now see with like great confidence, like looking at this, if I look at the primary coverage, I can look at secondary coverage, I can see that keeping these existing AP locations, it would most likely meet my requirements. Maybe you'd want to tweak something here or there potentially. Like if I want to, again, I can if I go back to primary coverage, I can grab an AP, I can move it around. If I wanted to, I can add an access point. This probably isn't a great example because of course Cisco are going to deploy a good Wi-Fi network in their environment. But however, if we saw, let's say that we did this upgrade visualization and we saw that there's a few gray spots or a few areas that wasn't quite meeting the requirements, then we could add in a few access points. I can still drop a new AP in here. I can move things around and tweak things. So this is a great way for you when you next have a conversation with your stakeholders, when they ask you, oh, Matt, can I, upgrade to Wi-Fi 7 access points, 6 gigahertz and keep my existing AP locations? You say, well, maybe just give me your survey data or let me do a quick survey with the Psychic 2 and I can check that for you, rather than going through that guesswork or worrying about putting up these APs and then not knowing until someone goes and does a survey after, and then you've got to run new cables anyway or run additional access points. It gives you that confidence to know that this will meet the requirements. So I think this is pretty cool. It's also super fast and really responsive, which using the online version. And again, yeah, I can just put it back to the same position or move it around. So just having a look at some of the chat and stuff, making sure I haven't missed anything there. So this was an example of doing a measured redesign, like an upgrade to your Wi-Fi network. Of course, you probably need to think about things like your switching, your structured cabling capabilities, but just from an RF perspective, this is a really great way to be able to visualize the coverage coming from the access points. And again, without having to draw kind of any walls or any obstacles. If I wanted to as well, I could actually just completely delete all of the access points that I've just placed here. So if I was to select all of them, I can delete, and now it's gone. And what I could do, if I wanted to, I could just place these APs manually myself. Maybe I want to use the 9178 version now. And what I can do is I can actually just place access points around the map manually myself, or we have an assisted planner that makes like suggestions for potential locations. I could use that, or I can just go around and place APs myself and come up with my own design. That's exactly where I was about to click as well. So yeah, a couple of different options and different methods there that you can visualize an upgrade or a redesign of a Wi-Fi 7 network for you. And the other thing that I wanted to show you was the traditional method of planning a Wi-Fi network. So what I've got here is just a warehouse floor plan, and I've already drawn the walls. So I've got I've got some brick walls, I've got some warehouse shelves, and I've got some drywall here, and I've got a couple of different spaces. So obviously we've got some long racks, we've got some office space, and then we've got like this palleted area down here. So let's say, for example, maybe I can't get to the warehouse to do a survey yet. Maybe it's a new construction going up and they want to get a rough bill of materials for how many access points you might need. I've run into this scenario quite a few times in my experience, that sometimes they just need to know how many APs they're likely to need even before the site is constructed. And then they will be happy for you to come on site once the materials are there for you to do the survey. So what I can do now, if I'm happy with how I've drawn all of my materials, again, I can go and grab the Cisco access point. 1 second. And then let's do the office space first, because that's nice and easy. So I'll grab the 917060i this time. And again, I can just come over here, place my access points. This is probably where I'd place the APs, 3 APs in this office space. Looks okay on 6 gigahertz. But the challenging spaces, I would say, would be the pallet areas and also the warehouse racks, because in an ideal world, you're not going to really want to place like a omnidirectional AP when you've got long racking aisles. You're going to want to use an access point that supports directional antennas to focus the energy down the aisle. And that can be a challenge when it comes to 6 gigahertz because like Jeff and Jim was talking about earlier, with 6 gigahertz, there's certain rules, especially around using outdoor APs and APs that support external antennas. So the fact that Cisco has an offering that has an integrated directional antenna now means we can actually design and deploy Wi-Fi in these spaces. So let me give you a quick little example. So this time now I'm going to use the D1, and if we look at the azimuth and elevation patterns, you can see that it's much more directional. So it focuses the energy of the radio coming out, the RF coming out radio in one direction with the antenna. So if I grab the D1, and let's say if I place it here, what I would need to do is just, I'm going to turn off the channels for a second to make it a bit easier to see. When I zoom in, you'll see we get a little arrow here. If I just point it this way, zoom out, now you can see that placing this access point down here, it will cover the aisle nicely. So it's on the wall. Of course, we can change the height, we can change the tilts. Maybe we want to have it tilted down slightly. I don't know, maybe like minus 20 degrees. Now we can plan to have these access points shooting down the aisles. So what I would probably do, I'm just going to copy and paste the access point, and I'm going to move one to here, and then I'm just going to put a couple down the other end of the aisles. And you want to make sure you install it in the right direction, because that doesn't look like a great heat map coming from the access point. So again, I would just shoot this down here, and then let me just put another one over there. Okay, so now we can see the coverage coming from these access points, and I can see that the aisles are nicely covered. But what I want to cover is these pallets as well. And typically with the pallet areas, they get stacked up to like 1 meter or 2 meters high. You may want to have a different kind of approach to cover the pallets. You might want to shoot from the top with a directional AP pointing down. You might want to have one of these APs on the wall. You can take a couple of different approaches. So if I copy and paste this access point, if I put it, let's say like over here, I can put it on this wall. You can see what it kind of looks like over here. Oh, and by the way, do you guys want to see something cool? Yeah, Jeff says yes. Okay, maybe you want to check out like how the RF or how your space looks like in 3D. So why don't I turn that on quickly? So actually now with Ekahau AI Pro Online, if I want to see how I've modeled my space, I can actually see it in 3D. So you can see we've got our racks. You can see I've got this access point currently turned on. Maybe I want to see what it looks like coming from this aisle. So yeah, I think that's pretty nice, pretty cool. I know a lot of people like to be able to see their space in 3D to make sure that they've built the environment correctly. Let me just jump back into the 2D design for now, because I want to talk about a couple of different approaches for the pallets areas. So you could go against the wall, of course, and maybe we'd have 2 or 3 over here to try and cover this space. However, though, if you've got people walking like along these sides of the pallets, that might, when these get full, it might block too much of the RF. So maybe I want to shoot from the top instead. So I can move these access points over to here. And actually what I would do is change it from being on the wall, and I would change it to be on the ceiling. And then maybe I would change the height to make it a bit higher, around 5 meters. And then maybe I would just copy and paste this access point again and put it over here. And then now when I look at my coverage from my design, it starts to look quite nice. But this is when I would prompt you to maybe have a conversation with your stakeholder, because this, from just looking at a coverage perspective, looks good. But what if redundancy is really important down these aisles, like having good secondary coverage? I wonder how that might look. So if I turn that on now, what you can see is there's actually a big gap in secondary signal down these racking aisles, because we've gone with well, I say I have done a design here. Maybe it's good, maybe it's not. I'll let you be the judge of that. But I've gone with one access point down each aisle. So when we look at primary coverage, you can see that's a good signal down the aisle. It covers the aisle nicely. However, when we look at secondary coverage, because there's only the one AP down the aisle, there isn't that secondary coverage there. So if, for example, this AP or this AP or this AP or this AP has a failure, when the racks are fully stocked and full, there wouldn't be another AP nearby to be able to provide that secondary backup coverage. And sometimes you need that secondary coverage for not just redundancy, but also for roaming, for the APs to build their neighbor reports and inform client devices. So if roaming and redundancy is really important in the warehouse, you might have to take an approach like something like this and put 2 APs down each aisle. And now you can see that you get that nice secondary coverage. So that was a quick live demo. I think it's nice to show that you had all of the amazing guys from Cisco telling you about the Wi-Fi 7 access points and how the different coverage looks. And now you can visualize it using Ekahau. So you can see the directional antenna directional antenna integrated access point, how that RF looks. You can take a look at the integrated Omni, and you can take a look at, using them in maybe some slightly different ways, a directional antenna pointing down, or, mount it on a wall, shooting down a racking aisle. Okay, that was a couple of slides and a quick demo on the AI Pro Online. But I do have another question for all of us in the chat today. And one of the things that I think around Wi-Fi that I probably think a lot of us can agree on is when you ask someone like, what is the biggest problem with Wi-Fi? I don't know how you feel about it, but I think I can probably get all of us to agree on something. I'm going to get, I don't know, all these hundreds of people to agree on the same thing. Biggest problem with Wi-Fi is it's not the Wi-Fi. I don't know how many times I've had someone call me up and complain or say the Wi-Fi sucks today, the Wi-Fi is not working, there's an issue with the Wi-Fi, yada, yada, yada. And then you start having a conversation with them, and then you start asking about the problem, and you find out actually it isn't the Wi-Fi, it's the DHCP server, it's the DNS server, it's the ISP, it's the captive portal, it's something else. So what we can really help you do now is get to that time to innocence of proving that it isn't the Wi-Fi a little bit faster. And that's because we are now integrating speed test into our Ekahau applications. So in our Ekahau Analyzer app, what you can actually do is connect your Sidekick 2 or your Sidekick, and you can run a speed test side by side with analyzing the Wi-Fi spectrum data. So in this scenario here, you can see that actually the RF looks good. My spectrum is clean, I've got good signal strength, I've got low channel interference, I've got good channel bandwidth. However, I get really slow speed test results. So straight away, that's a good indication to be like, oh, you know what? When the person calls you and says the Wi-Fi sucks, you say, no, it doesn't. You've got a problem with your ISP or someone's capping your bandwidth. So it helps you to get to that point much quicker. And then we all live and breathe on video calls today. I'm sure we can agree on that as well. I don't know how many times sometimes people join a call and their video quality sucks, or they have to be like, oh, Matt, can you just turn off your video? You're a bit choppy, a bit out of sync. That's really frustrating, right? Well, actually, there's a test that you can run inside a speed test that actually will run a test on your video capabilities. So it'll run a real video application test. And again, now checking against the Wi-Fi too, to see if your network will be able to handle a video call or what kind of quality you're likely to be able to achieve. So this is going to be a really nice thing to be able to see. This is coming soon. The speed test integration is actually available right now, but this will be something that's coming very soon that you can get a little bit more granular with some of your tests running inside of the Analyzer application. And last honorable mention is that Down Detector will also be featured in the Ekahau applications too. So if you're wondering if it's TikTok that's down or if it's your device is having an issue, I know Jeff likes to do a lot of fun dances. I've seen the Cisco TikTok. There's a lot of great content on there. If you haven't, if you haven't checked it out, I'd highly recommend going over there. But it's a great platform to be able to really understand that if there's any like big network outages or there's some particular services down. If you think back recently, that whole CrowdStrike issue that happened, you can now be able to see that inside the apps, giving you that visibility, which is really handy. We have some giveaways that we're going to be doing. So this is going to be something that we do post the event. So make sure you stay tuned in your emails, and we'll be picking some random winners. We're going to be giving away some video on demand training, as well as some swag, some beanies, some socks. I definitely need them over here in the UK and around Europe right now. I can see a lot of guys and girls that are joining around Europe that are going to be thankful for having a nice beanie and some warm socks, and then the really nice Cisco Yeti to keep your hot beverage of choice nice and warm. And on that note, I want to say a huge thank you to the Cisco team for letting us come on today and speak to so many of you amazing people about Ekahau and Wi-Fi, and especially Wi-Fi 7. I personally loved this session, just sitting back as an attendee, enjoying Drew, Jeff and Jim's content. It was really great stuff. So, and thank you for having us.
Matt, thank you so much. That was awesome. The performance of the AI online spectrum, unbelievable. That was actually kind of took me back. I've used a lot of different tools over the last 20 years. I want to use that one. I don't really want to do every site survey, but I want to use that tool at least once.
All I
Another
have
call
to,
out, Matt. Sorry.
no, I was just saying, all I have to do now, Jeff, is just send you that survey data, and then you can just play around with it in the online browser from wherever you are.
That was super cool. I mean, very smooth operation. Loved it. I think a lot of people in the chat were quite impressed. When you went into 3D mode, I think you opened up the matrix as well. So I might know Kung Fu as well. Matt, one bit of call out. Next time we invite you into our house in the Cisco Paris office, don't start war chalking the entire environment. Come on, you were a guest in our home and you're out there with your wireless analyzer. That's funny. Clearly, you're a true wireless engineer. And the other call out as well, it doesn't matter what generation of Wi-Fi hardware y'all are deploying out there. Without a solid layer 1 design, it is going to be the Wi-Fi. A solid layer 1 design using tools like Ekahau's planning tools, that is going to enable success and enable, like, pervasive wireless coverage for multimedia, for location applications. That was great stuff today, Matt. And Jim, thank you so much for sharing all of your expertise and your thoughts. Drew, thank you so much for walking through the portfolio. And to the 170 participants that joined us live today, thank you all for your time. We really appreciate it. We know that this was a 90-minute session, a little longer than the usual format, but we just couldn't jam this into 60 minutes. So thank you all for sticking around for 90. We are absolutely going to send out the slides and the recording, so you all can share it with your friends, review it again. This was a nutrient-dense webinar here today, and so I think I'm gonna have to go and rewatch some of those segments just to make sure I caught everything. But with that, I want to say happy holidays to everybody. Thank you all. Thank you, Matt. Thank you, Jim. Thank you, Drew, and thank you everyone out there for attending. Have a great rest of your day, and cheers. Happy Wi-Fi 7 launch.
Yeah,
Everyone,
bye,
take care.
everybody.
Thank you, guys.
Yeah.
Happy holidays to you too, sir.
That's right.